As we go on to topic 3 of chapter 2, again, write these out on the left side of your booklet. This is your model of the steps that if I see this in your blue sheet or on your blue sheets when we do the test, that's going to be really well done, and what I'm looking for also in your homework logs. So these are the models that we're working on. So we'll give you a chance to copy row 1 down, and then we'll go on to solve them. So we've cleared parentheses. Notice here we're changing the sign of both terms as we remove the parenthesis with a negative in front of it. Now we group like terms. This just becomes a 1A. Now we're going to introduce a new technique. You can use the old technique of subtracting 1, but we're now going to introduce this idea of transposition. When you take a term from one side of the equation and move it to the other side, it just changes its sign. So this then becomes 3. So A equals 3. Now this is a shortcut. In essence, what we're doing, just so you know, we're subtracting a 1 there, and we're subtracting a 1 there. We're doing what we've done. We're just using this technique of transposition. When a term goes from one side of the equation to the other, we just change its sign. It's a good little tool. So for instance here, we're going to take this negative 4, transpose it. On this side it becomes a positive 4. So we get 12b equals 20. And now we're going to divide both sides by the numerical coefficient of b, which is 12. And then we reduce to lowest terms. We can take a 4 out of there, and that's going to be 5. And a 4 out of there, and that's going to be 3. So we get 5/3. Now, here, since the 72 is already on this side, where normally I want to keep my variable positive, you can do it either way, but we're going to transpose the 16 to this side. On this side it becomes a negative 16 C. So this leaves me with a negative 12 C equals 72. And now we have to divide by the numerical coefficient of Z, which is a negative 12. Now where students sometimes make an error is they'll forget to put this side by a negative 12 as well. They'll just do 12. So they forgot the negative sign, but don't forget it. So this cancels out, it becomes a positive Z equals a negative 6. Okay, again, this would be satisfactory for showing the work, where you've written out the example, you distributed, and then you've transposed, and then you've solved for the isolated variable. Okay, we're going to write this row down, and then let you get rid of parentheses. So we've gotten rid of parentheses. Now we want to get all of our variables onto one side. And we study it a little bit. Here, if we want to keep it positive, we're going to transpose this term, where it on this side will become a negative 2x. This will just become an x. And then when we transpose this to the other side, it becomes a positive 15, so this is a 31. Now again, we're using some shortcuts. If you need to write out all the steps, that's okay. You want to get it correct. But as we move along, we do use shortcuts. So again, we're going to transpose this to the other side, and over here it becomes a negative 5a, so we're just left with an a. Now we're going to transpose this to the other side, and it's a negative 9 on that side. On this side it becomes a positive 9, so this gives us 29. Now here, as we look at what we have, we're going to transpose this to the other side where it becomes a negative 3c. So this is going to be 45c. Now we're going to transpose this to the other side where it becomes a positive 24. A positive 24 and a negative 4 leaves me with a positive 20. Now again, you can write out the steps, but as we move along, we're allowed to take shortcuts and then check your work. On this side it was negative, on this side it becomes positive, and we can just mentally add that together. Now to get our answer, we have to isolate the c, so we're going to divide by the numerical coefficient. Here this cancels out and we're left with c. Now here we can take a 5 out of each one, so that's 4/9. Now if you left it this way, MathLab would count it incorrect. But because you showed the work, I would probably give you half credit, or maybe even more. Again, we're looking to see the work in a neat and orderly way, and we've now introduced the concept of transposition. Now in number 2, as we look at these, we see these contain regular fractions and these are decimal fractions. Now we had a hint. We want to multiply each term by the least common denominator. And how many terms are there? Well, there's 1, 2, 3. 1, 2, 3. Now because of the division bar here, this is just one term, another term, and another term. So now we need to figure out what will be our least common denominator. Well, here there's no choice, it's 6. So we multiply every term by 6. Now here we're going to choose 8. That's the least common denominator. And here we're going to choose 4. And we could, in a sense, put that in a parenthesis because of the division bar. A 4 for each term. Okay, give you a moment, work these out, and see what your next line will be. There'll be no fractions. Did you get this? Here the 6's cancel out, and we're just left with the y. Now negative 4 times 6, negative 24. 6 times 1 is 6. Now here 4 goes into 4 once, 4 goes into 8 twice, so 2 times 1x is 2x. Here the 8's cancel out completely, and we're just left with 3x, and then this is 40. Now here the 4 canceled out completely, so we're just left with what is on top of the division bar. This is 4x. Here the 4's cancel out completely, and we just get a negative 5x. So much easier to deal with when there are no fractions. So here we're going to get y. We're going to transpose this, where on this side it becomes a positive 24, and we get 30. Here we're going to group like terms. We end up with a negative x equals 40. Divide both sides by a negative 1, or just change the signs. A negative 40. Now again, we want to have our x is positive, but we have to group like terms first. So this is negative 6x plus 9 equals a negative 5x. So we want positive values, so we're going to move this over to the other side, where it becomes a positive 6x, which just leaves us with an x equals 9. And these match up and check. Now we did some of these on the other page where it contained decimals. 2 places, 2 places, and here we have to add 2 places. Doesn't mean anything, just adding zeros, as long as there's a decimal point there. But now multiplying each term by 100 here, we just move the decimal place over 2 places. And again, this is one term. This is all just one term because it's indicating multiplication. And this is one term. So we now get 5x plus, this is 6 times x is 6x minus 90,000. And you might say, how come you don't move any decimals here? Because you just move it to one of the factors within a term, which we did. We don't do it here. This is just one term. And then that equals, and be careful of the zeros. So we add this together, and this becomes 11x. Transpose this to the other side, add it to it, and that becomes 66,000. And now we divide by 11. And it comes out even as a nice 6,000. Now we'll be doing some word problems like this later. This is how we would solve once we converted the word problem into an equation. Get rid of the decimals. It makes it much easier to do. And of course, as you do the practice and you put in your answer, you see right away if it's right or wrong. If you're working and getting them right, that's excellent. If not, then you have to check your work carefully. Now, 1 decimal place here, 1 there, 1 there. Again, 3 terms. So we're going to multiply every term here by 10, which just moves the decimal place over 1. And let's just do that. So this is 4x plus 27. How about 28 here? Yes. And this is going to be a negative 1 now. Just reverses these signs. And that's a negative 8 here. All right, let's continue. So we group like terms. 4x minus 3x is x. A 28 and a negative 6 is 22. We transpose this to the other side, where it becomes a negative 22, and a negative 8 gives us a negative 30. So these check out. Now, for a little background, for number 3, we want you to indicate if it's an identity or an equation with no solution? Well, first of all, if we look at what I've written here, 2x plus 3 equals 2x plus 3. And you might say, well, geez, what's on the right is exactly what's on the left. Now, if I subtracted 2x from both sides, I would then get 3 equals 3. Now, is that a true statement? And the answer is yes. When you fiddle with your equation and end up losing the variables, but have a true statement, we call this, and you can see it right there very clearly, an identity. So what's the solution for something that's an identity? Well, if you put a 5 here, and you put a 5 here, this is 10 plus 3, 10 plus 3 is 15. If you put a 2 there and a 2 there, in fact, you can put any number there, so long as it's the same number there, and it would make it a true statement. So when we have an identity, the answer is all real numbers, and we usually use that symbol. So for an identity, and it won't look like this initially, you have to fiddle with it, and then it looks like this. And if you start to solve it, you see the variables will cancel out. You end up with a true statement. This is all real numbers. Now, as you look at this one, and we're going to subtract out the variables from both sides, we then end up with 3 equals 5. Is that a true statement? And you might say, no, it's not a true statement. So, are there any possible solutions that you could put for the x that would make this a true statement? And the answer is no. So when you have something like this, the variables cancel out, and you're left with an untrue statement, this is not true, then there is no solution. Now, as you do these, again, you don't know whether they're identities or whether there's no solution. You have to kind of put it into a recognizable form. So this will be 6z as we distribute plus 42 equals 6z plus 42. Oh, well, this one's jumping out at us, and we don't have to go beyond this. You could subtract out the 6z's, but this is an identity, so it's all real numbers. It's an identity. Now, how about this one? We're going to group like terms. 12x plus 2 equals 12x minus 1. Now, when we subtract out the 12x's from both sides, we get 2 equals negative 1. Is that a true statement? No. So for this one, no solution. Now here we're going to use our technique of getting rid of the fractions by multiplying every term by what? Just say it out. 6. And there's 2 terms on this side, 2 terms there. You have to multiply everything by 6. So here this cancels and we get 2x minus 18. Here the 6's cancel out and we get 2x plus 6. So you couldn't tell before, but now that we got rid of the fractions and we're going to subtract out the 2x's, we get negative 18 equals 6. Is that a true statement? No. So no solution. Now in our next section we're going on to word problems. I strongly advise you to get caught up on mastering the skills of solving equations. and following those 6 rules that we suggest you use in the sequence of solving any equation. And good luck.